Okay, welcome to the next lecture on boxing, strings, and sneaky allocations. Okay, it's going to be a very short lecture as well, but these are things that are sneaky and these are very common as well. So let's look at each of them. So, what is boxing? Boxing is when you convert a value type to an object type. It's as simple as that. So, let's say there is an object, okay, object of type O, and then there's an integer. Let's call it score. And because object can store literally anything, we can say O equals score, right? It is possible, but this leads to boxing. Okay, what do I mean by this? O is a reference type and score is a value type. This is an integer, right? We talked about this before. Because this is a reference type, this is stored in the heap. And because this is value type, this is stored in the stack. Okay, setting a value in the stack to the heap. Now, what this creates is a new heap allocation. This allocates memory inside the heap and then it will set it to this one. Okay, so that is what boxing means. Let me give you another example. This is way more common when we write debug.log score plus score. Now, score is actually value type, right? This entire thing is a string. We learned earlier that string is stored in the managed heap. Now again, you are converting this value type into a heap. So this will lead to boxing. Now, if such a code is being run continuously, then it leads to GC pressure, okay, or allocation pressure, and that will cause spikes. Okay, so boxing is very important to look into. And one more thing is to look into strings. Strings are also a common problem for GC, especially when we use the toString function. If we say score.toString, this will create a GC. It's not inherently bad, and there are sometimes no ways around it. Okay, you can use something called string builder. String builder creates a non-GC version of a string, but it does have its own drawbacks that you need to research into. Everything will have its own drawbacks. Okay, so don't worry about a perfect solution in game development. String builder also has its own toString function as well, which will also cause GC. Also, when you do string concatenation, if you say A plus B, that causes GC. So you're not supposed to concatenate strings together unless it's absolutely necessary. So only concatenate strings when it's needed. Try to learn string builder. It's really great. But at the same time, it has its own drawbacks. And what do I mean by the drawbacks? String builder doesn't completely eliminate GC. It just reduces GC. How do I say it? So instead of saying stuff like score plus space, coins plus coins, this is a bad way to concatenate. This is bad. We can use string builder to append. Okay, it uses a function called append, and that eliminates a lot of garbage, but it doesn't completely eliminate it because you are creating a new string builder instance, and then you are also sometimes using toString there as well. So it doesn't completely eliminate it. It's way better than doing this, definitely. So yeah, these are just things that I want to mention here. Now, 2 more lectures before we actually start profiling. The next one is on object pooling, which we'll cover it shortly.